After doing my video on SDVOE latency measurements, I got the request to do the same thing for Crestron NVX, Crestron's 1 gigabit AV over IP solution. In this video, you will see the result. For those of you who didn't see the video, I use an HDMI to VGA adapter, a customized one frame red video clip, and a cheap oscilloscope for this measurement. More information can be found in the SDVOE latency to the test video. The Crestron equipment used is an encoder, the E30, and a decoder, D30. So here we have our first setup. We start with a laptop playing the one frame red video clip at 1080p60. The HDMI output of the laptop is going to an HDMI splitter. One output of the splitter is going to an HDMI to VGA adapter, and the other output is going through an NVX system, encoder, switch, decoder, again to an HDMI to VGA adapter. What we're going to do is we're going to measure the red signals on the HDMI to VGA adapters and compare them on the oscilloscope to measure the latency. So here we have the same setup, only this time in real life. You see the Cisco switch. The Cisco switch has PoE support and powers the Crestron units. But I ran into some issues until I realized that the Crestron NVX units need PoE Plus, the 30 watt version of PoE. So I used PoE Plus injectors to solve the problem. This is the oscilloscope measurement. The first measurement showed a latency of about 33 milliseconds. That's about 2 frames at 60 Hertz. And this seems kind of high. So I did a second measurement, and this measurement showed about 20 milliseconds of latency. So I did additional measurements, and I noticed that the latency seemed to decrease over time. And the latency finally settled at about 9.6 milliseconds. I wanted to further investigate this effect of decreasing latency over time. So I used the exact same setup as before. The only difference is this time at the VGA adapter, we're going to measure the vertical sync pulses instead of the red signal. And I put a stopwatch next to the oscilloscope to see the timing effect. I plug in the HDMI cable in the encoder. On the oscilloscope you see the yellow vertical sync pulses, the reference pulses, and in blue the vertical sync pulses coming from the Crestron NVX. I put the video in fast play to save some time, and you can see that the sync pulses of the Crestron NVX are moving. So what you're actually seeing here is the decreasing of the latency. The stopwatch is running until about 3 minutes, and then the latency settles. And when we're going to zoom in on the oscilloscope, we will see that the latency is about 9 milliseconds, the same value that we measured in the previous measurement. Conclusion. For Crestron NVX, I measured the latency of 9.6 milliseconds at 1080p 60. That's about 0.6 frames at 60 frames per second, or just over half a frame. It takes about 3 minutes to reach this maximum latency after the HDMI cable is plugged into the encoder. And according to Crestron, this is due to the video wall setup, although I didn't use the video wall feature. Thank you very much for watching this video. If you want to see more reviews, please check out my website wavepart.nl/reviews. Please leave your comments below this video or send me an email at jeroen@wavepart.nl.